Okay, I'm going to show you a little bit about optimization and indexes and queries. This is right now we're using the climate change DB, and I've created a query here that joins several different tables. It joins event, location, event topic, and topic. And what it does is it shows the event name, topic name, location name, address, city, district, country, and postal code. There's no data in our database, so we get this empty query. But I want to show you, I'm going to highlight it again to run it. I'm going to use this little hand that says explain. And when I run it, it will give me a picture of the query. All right, so it shows me in this, there's the table, event topic, there's an inner join, which creates a hash. My mouse, there it is. Another table, another inner join. Each of those inner joins costs quite a bit of time. Now this doesn't give us the actual costs in terms of the time because there's no data involved. There's also the statistics, which will give you a again a count of the different hashes and joins and sequences and etc. And there's an analysis that gives you another thing. You would have a lot more information about this if there were data, and I will show you one with data in a soon. But you can use this diagram to help analyze what the cost of a query is. All right, and there's a couple of ways to deal with this. One is you can create indexes. And in this one, probably what are people going to be searching for? So I'm going to just do a couple. These you can use for your assignment, but I'm not going to do all of the indexes that I think you would need. I am going to create an index, and I will call it event IDX, an event index. Okay, so it'll be on a particular table. These don't have to be capitalized, but to be consistent, I will. So we're going to do it on the table event, which is red because event is a keyword, and I'm going to do it on event name. All right, so that will create an index on event name. I'm going to do that. So when you're searching for an event by name, this will help. It'll create that B tree, and you can see. So I'm going to right click, and I'm going to refresh, and I'm going to look under event, and I'm going to look under indexes, and you'll see that there's an event IDX, right? So we've created our event IDX, and that might speed things up when you do a query. You can also do, I'm going to do one other, I'm going to create index, and I'll call it event location IDX on location, which is also a keyword. Location name. Now you might also want, because that is again could be a criteria. Location name is spelled wrong in this database. Some of my dyslexia there. I'm going to copy it and paste it down here. Okay. So those are creating indexes. Now it probably will have no effect if we were to run this now, because we have no data. Oops, I wanted to do this. All right. Does it? I doubt if it shows any use of those indexes. It would only use those indexes if it helped, and with no data, there's no help to be had. All right, I'm going to try to create a materialized view. And again, there's no data. And I'm going to do all of this again in a moment with data. But a materialized view combines all of this and actually loads the data into it. So I am going to do create materialized view. Those should both be capitalized if I'm consistent. And we're going to give the view event locations. Okay, and we're going to do this as, and then I'm just going to copy this data. And I'm going to add one thing here. I'm going to say with data. All right. And so I created the view. And if I do select star from event locations, you'll see that I'll get the same fields, empty fields as before. I'm curious if I analyze this as a, if it will be, see, it's much faster. There's just a table, there's not all those joins. So that's another strategy. Now the bad part of this strategy, as I've said, is that when you do this materialized view with data, the data is not live. You have to refresh it in order for the data to be live. Let's look real quickly at these three things again in a different database. Now again, your assignment is really just to come up with a list of places where indexes should be on anything that are going to be part of queries a lot. All right, so I'm going to go to a different database here. I am going to go to, let's do the tech certificates. This is my review copy of changes, revised. I'm going to get a new query tool. And I am going to create a query that does, and so I'm going to do basically for student information. First name, this will be a large, have a fairly large signature. So I'm going to do first name, last name, student start date, what else do I want to do? Let's just do an average final grade. Is there anything else that I want? Let's do student ID up here. Student key. Okay. So we're going to do from person, and we will join student. And I'm going to do using again, using person key. And then we're going to join, really we only need roster. So I'm going to do using student key. And then just to add let's add a where condition, or let's add a, first of all, we need to do a group by. And we need to group by student key, first name, last name, and student start date. Literally anything that isn't there. And we probably need to clarify that this will be student key because it's in two different tables. And then I'm going to add a criteria having average final grade, and we'll say greater than 3.5. All right. So we'll run this, make sure the query works. Let's do, since we're doing this, let's format this so it's easier to read. We'll round it. Okay. So these are, we've got 17 only 17 students have averages above 3.5 out of 200. Interesting. All right, so let's look at that as a, so we've got a roster, right? And we've got the inner join, and we've got another inner join, we've got an aggregate, we've got another table, we've got another join, and a table and a join. All right, if we look at the analysis, it goes through how it does it, statistics, gives us some more information about those things. Doesn't give us costs. Is there a way to get the cost? This data output, if you look at it, it gives us, I'm going to copy this. I'm going to and then I'm going to close that comment. All right. It gives us a JSON thing of all of the different elements in that diagram. Okay. So that's sort of interesting. Okay. Now we could create indexes for this, and I do not know. Let's do a I'm just going to create one index. Create index. Let's do on person key. So we'll say person IDX on person dot person key. And so, oops. So I'm going to create that index. Okay, I'm going to see if this makes any difference. Is that index used anywhere? It actually is not. And again, I think it's because the data is not, there isn't enough data. But again, this could speed things up because person key is used a lot to look these things up. Let's do one other thing. Let's turn this into a materialized view. Create materialized view. We'll call it 3.5 and above is call it honor roll. As, and we'll just give this whole thing as the body. Okay, and we'll take that off and we'll add with data. So we're creating a materialized view. All right. Now, if I do a select star from honor roll, I should see all of those people again. Okay, so but these are physically in the view right now. If I run this, again, it only has the single table. It's a lot faster to pre-combine it, with the caveats that it doesn't reflect current data unless you refresh it. The way you would refresh it is you would just say refresh materialized honor roll, and that would add any new data that was there. Oh, that's because I didn't highlight the whole thing. There we go. So it would refresh it if it needed to. And you would want to do this fairly commonly, fairly often. Alright, so that's going to be my presentation, just another presentation on this. Again, all you have to do, if we go back to climate change here, is think about where all of the indexes would be valuable. You know, what fields would they be? And then create some indexes for that. If you want to try creating a materialized view, you're welcome to, but it's not part of the assignment. It is, though, a useful strategy for optimizing. All right, so that's it. I am